Right. I'm sorry, my attention was a bit interrupted in answering question 7.2.3, so I made a mistake, and I'm not going to rewrite the whole explanation. But from question 7.2.2 we get that the concentration of the hydroxide ions in the solution after neutralization is 0.01. Therefore, and we know that the concentration of hydroxide ions equals the concentration of sodium hydroxide ions, because the ratio is 1:1. So the concentration of the sodium hydroxide that was not neutralized during the reaction with hydrochloric acid is 0.01 mole per cubic decimeter. Now, we have already calculated that 2.5 times 10 to the minus 3 mole acid will neutralize the same number of mole base, because they react in the ratio 1:1. Now at the end, the mole sodium hydroxide left unreacted can therefore be calculated by using N is equal to C times V. Now this volume can't be the 35 cubic centimeters that we started off with, because this volume is the volume of the solution after 25 cubic centimeters was added to 35 cubic centimeters. So the volume of the solution would be 60 cubic centimeters. That must be multiplied by the concentration of the sodium hydroxide to get the mole of the hydroxide that was left unreacted. And when you do the calculation, you get that it is 6 times 10 to the minus 4 moles. Now, 6 times 10 to the minus 4 moles was unreacted, and 2.5 times 10 to the minus 3 moles reacted. So the total moles that we started off with must be the reacted plus the unreacted, and that brings us to a 0.031 mole sodium hydroxide. So that is the moles that we started off with, and that came from the 35 cubic centimeters. So the concentration of the sodium hydroxide in the 35 cubic centimeters was 0.0886 mole per cubic decimeter. But they said that that solution was diluted a tenth of the original solution. So to get the original solution's concentration, we need to multiply this solution by 10, and you get 0.89 if you round it to 2 decimal places. I'm sorry for this interrupted video. I hope it will make things clear for you.